I want to do an example where we have a repeated eigenvalue that has, well, actually we're going to do a multiplicity 3 eigenvalue where there's only one linearly independent eigenvector you can find from doing the row reduction after plugging in the eigenvalue. Just to give you an example of how we work with that. So we're going to solve the system. X prime equals 1, 1, 1, 2, 1, negative 1, negative 3, 2, 4, x. So we've already got our system written in matrix form. So let's switch over to GeoGebra. We're going to type in the matrix here. 1, 1, 1, 2, 1, negative 1, and negative 3, 2, 4. And we'll make this into a matrix. And define our new matrix B, just like we have in all the other problems we've done with this. And take the determinant of B to see the characteristic polynomial. And in particular, I'm going to factor this one rather than solving it just so that we can actually see that we really do have a repeated eigenvalue of 3 in this particular case. We really do get 2 is repeated 3 times for the eigenvalue. However, if we substitute into B and change the x to a 2, and then row reduce it, we see that we're only going to get one linearly independent eigenvector. Notice that we get the first component has to be 0, and the second component is negative of the third component. So we're going to get an eigenvector of 0, negative 1, 1, but that's the only one we get from this one. So just to write that down, we get our lambda is 2. It's repeated 3 times. Multiplicity of 3. And we get our eigenvector, our k1, is the vector 0, negative 1, 1. All right. So remember now, we can get to this point. We're going to have other solutions. So our x1 will be, again, it'll be c1 times 0, negative 1, 1, and then e to the 2t. Actually, I guess technically I didn't need to put the constant on there because we can always do the superposition principle on that later on. But this is going to be one of our solutions. So we're going to assume our C2 then is a C2 times our K times TE to the 2T plus some P times E to the 2T. This is going to be our assumption. We got to figure out what this P is. And then also our X3 will be C3 times KT squared over 2 E to the 2T plus PTE to the 2t plus QE to the 2t. And then we got to figure out what this Q is after we figure out the P. Remember from class, we already know that we have the A minus lambda I times the K is equal to the 0 matrix. The idea behind this is the A minus lambda I times P has to equal the K matrix, and the A minus lambda I times the Q has to equal the P matrix. This is why we have to find the P before we find the Q. All right, so going back over to GeoGebra, this is where we've subtracted 2 off the diagonal. This is A minus lambda I right here. I need to augment that particular matrix, and it looks like up in my line above here, I can't grab it. So I think what I'm just going to do is go back over here to this matrix. I'm going to just, I don't want to do it there. I think I'm going to retype the matrix after subtracting 2 off, which was the one that's in line 4 there. Negative 1, 1, 1. And we're going to augment the matrix 0 here, and then 2, negative 1, negative 1. I'm going to augment negative 1 there, and negative 3, 2, 2, and I'm going to augment 1 there. Remember, we're doing the A minus lambda I matrix and augmenting it with the K eigenvector we want to solve that system. So I want to take this, make it a matrix, call it, I think I've used A and B, so we'll call it C. I don't know why it does it every time. It drives me crazy. Create. Back down here, we want to reduce row echelon form of C. So now we can figure out what P is, and we just need one vector for P. So notice that the T can be anything, or excuse me, the third component can be anything. So if it's a 1, then we get -2 for the second component, and we definitely get -1 for the first component. So our P vector then will be 0, -2, 1. Now that we found that excuse me, that wasn't 0. That was -1, -2, 1. Sorry about that. -1, and then we subtract the 1 over, we get -2, 1. Now we can do the same thing here. Now in this case, when I've already augmented with this one, if I change what the vector is here that we've augmented, it should change it automatically in our computations over here on the left. So I want to put in the matrix, or excuse me, the augmenting with -1, and then it was also -2, 1, except I didn't type in -2 there. Let me go back up here, -2. So now we've got this solution. We've got the first component has to be -3, and the second component here is, well, -4 plus, or excuse me, minus the third component. So if I make the third component 1, we get -5. So our Q will be -1, -5, 1. Go back and check and make sure I wrote the wrong thing. Yes. So now it's just a matter of plugging those back in up here to get our solution, which I'm not going to take the time to do because you can plug it in. You put your K in here and your P in here. That will give you your X2. You plug your K in here, your P in here, your Q in here. That gives you your X3, and so the sum of those three things would be your final answer.